Hi, in this video I'm going to present Vision CT, a desktop application I built for processing CT scan slices, specialty in the lower abdomen region. The idea is simple: load the CT slices in deCOM or IMA format, run it through a full computer vision pipeline, and obtain a final segmentation of three regions of interest: fat, muscle, and bone along, with some useful statistics and visual analysis. Context and problem. The challenge with abdominal CT scans is that the structures are mixed and sometimes subtly. Bone edges are very sharp. Muscle creates softer contours around the femur, and fat is distributed both subcutaneous and viscerally. If you only look the grayscale image, it's hard to clearly separate these tissues. So I built processing pipeline that goes from normalization, contrast, smoothing, edge detection, thresholding, mask, and finally a color overlay that makes the anatomical regions easy to interpret. 3. Overview the application. On the left, there on the pull panel with all the stage of pipeline. The center panel shows the image being processed in real time. At the bottom, there is a log that records each operation I run. The base pipeline, load and normalization. Internally, I'm using ITK to load the deCOM data computation to save math. This normalized image is the base for all the layer operations, contrast options, clay, and construct stretch. Contrast stage with stretch the dynamic range. Clay, which is adapted to histogramming equalization. Smoothing options. Apply Gaussian show a median and log buttons. Gaussian blur is the primary filter. I reduce noisily while preventing important controls. Log is optional but interesting to compare because it changes how they appear in the pipeline. Optional range, DNSN, neural, denoisely. In test of Gaussian blur, I can run the image through the CNN, which removes noisily while keeping final structure detail. After that, the pipeline reconnects Sobel and continues normally. Edge detection, Sobel and Canny. Sobel. Sobel gives in the main gradients of the CT slices. I can clearly see the femur contours. Canny. Then I apply Canny where the thresholds are very important. If the thresholds are too high, muscle disappear. If then they're not too low, internal bone noisily appears. Masks. Fat, muscle, and bone. Based on intensity range, I generate three masks: fat, muscle, bone. Logical operation and overlay final. Finally, I combine the mask using a simple OR operation and generation the final over. Colors: blue for fat, green for muscle, red for bone. Statics result and histograms. I also computed basic for age regions, number of pixels, mean intensity, standard deviation, percentage of age. These values make sense for this anatomical location. I included histograms, one for muscle and one for bone. Memory usage. I also monitor RAM was usable while processing several images. Most operation loading, normalization, smoothing, mask, stylable. The only noticeable spike comes from the DNSNN slice its run a full neural network but is still stay within reasonable limits. Closing. A complete modular system that supports different normalization options, multiple smoothing techniques, classical edge detection neural, denoising segmentation mask, morphology refinements, and a color overlay design specifically for set slices of the lower abdomen. Thanks for watching, and I hope the project is clear and useful.